Okay, students, so this is the induction lesson for Cheshire Grammar students, year 12, and today we're going to be looking at a part of the maths curriculum that isn't touched in GCSE maths, and that is calculus. Now, many of you will have heard the word calculus before, but you possibly won't really know what it's referring to. So today we're going to look at what calculus is, and we're going to do some basic calculus. So the first thing I'm going to do is share with you my screen. So hopefully you can now see the GeoGebra page. So I'm going to go to Start Calculator and we're going to look at a simple quadratic graph. So this simple quadratic graph is x squared. Now I was going to have this prepared in advance for you, but I thought it'd be good for you to actually see me plotting the things on GeoGebra, just so if you're not already familiar with the use of GeoGebra, you can see how it works. So all I've done is input this curve y equals x squared. Now what I'd like to do is think about the gradient of this curve. Now you're used to looking at gradients of linear lines. So if I was to plot I don't know, the curve y equals 3x minus 1, you'd be able to tell me that the gradient of that line is 3, and it's always 3. It's a straight line, so it's got constant gradient. But this curve, its gradient isn't constant. Now, we define on a curve the gradient at any point to be the gradient of the tangent at that point. So what I'm going to do is I'm going to pop it, if I go to this little bar at the top, I'm going to find a point. I'm going to pop a point on that curve. Now I've got to be careful. If I want to move that point, I have to select this arrow here, and I can move that point wherever I want, and it'll just stay on the curve. So what I'm then going to do is draw a tangent. Now if I scroll down my menu here, I can find tangents. Press on my curve, my point, and I press on my curve here, and I can go back up, grab my arrow, and now I can move, and I can see what's going on here. I can see what the tangent is as I move my point A around. So can anyone tell me about the gradient anywhere when x is negative? So if anyone would like to give me an answer to that, you can talk on the microphone. What can you tell me about the gradient here when x is negative? Anyone brave enough to speak? Or I'm going to have to pick on people.
It's negative.
It is negative, yes. Thank you very much. Who was that?
Carl.
Carl, excellent. Thank you, Carl. And what about when x is positive? What can you tell me about the gradient over here when x is positive? Someone else?
Positive.
It is positive, yes. I think that's what that word was. Yes, it is positive. And down here, when x is 0, of course, we've got a gradient of 0. So what I'm going to do is I'm going to put this point here when x equals minus 1. Now, if we just think about our triangles, we can see quite clearly that when x is minus 1, my gradient is, well, I go 2 down for 1 across. So the y value is changing by 2. Downwards, the x value is changed by 1, so that the gradient is going to be minus 2. If I put my x value here when x is minus 2, I can see that the gradient of this line is minus 4. Now I'm going to plot a little table here. So when x was minus 2, actually I don't want y, I want to find the gradient. So I'm going to say m. So when x is minus 2, the gradient is minus 4. When x was minus 1, the gradient was minus 2. We said that when x is 0, the gradient is 0. Now also, this curve is symmetrical. Oh, wrong one. That was one I made earlier. This curve is, let's get rid of that one in fact. This curve is symmetrical. So therefore, when x is 1, the gradient is 2. When x is 2, the gradient is 4. So I've got this symmetry here. So when x is 1, the gradient is 2. Now, I'm sure that you can all tell me what the pattern is here. I can say that the gradient at any point on x squared, so the gradient of x squared, actually let me write that a bit more clearly. The gradient of y equals x squared is what? Is anyone able to tell me what's the relationship between the gradient of x squared and the x value? Can anyone tell me?
2x.
2x, absolutely. 2x. Now, this calculus is all about rates of change, and this is what we're doing. We're finding the rate of change at any point. So it's very easy when I plot the point on, say, x equals 1 to just look at the triangle to figure out what that gradient is. But I could do it at any point in between 1, x equals 1 and x equals 2. So I could use this and say, well, when x equals, say, 2.7, the gradient equals 5.4. Okay. Now, what if I wanted to know the equation of the gradient? So I've got the gradient. I've also got a point that the gradient goes through. So say, for example, I wanted the equation of this line. So x is 1, y is 1. I also know, pardon me, I also know that it goes through the point 1, 1. So if I was looking for the equation of the gradient, the tangent, let's use my rubber here. I'm looking for the equation of the tangent to y equals x squared at the point 1, 1. Well, I know the gradient of that tangent is going to be 2, because we've already discussed over here that the gradient is twice the x value. And so I'm able to say I can either use y equals mx plus c, and I know that m is 2 and y is 1 when x is 1 in order to find c, or I can use something that some of you will be more familiar with who've done the further maths GCSE of m equals y minus y1 over x minus x1. Now, if I use this second one, and this is something that you're going to have to get very used to in A-level maths, I can say, well, the gradient of this tangent is 2. I'm just going to do this in a different color. So this is going to go down here. So I'm going to say the gradient is 2. My y1 and my x1 are specific points on that tangent. So I know that it passes through the point 1, 1. So I can say y minus 1 over x minus 1. And this is actually the equation of a line. If I expand this out or multiply this out, so I multiply both sides by x minus 1, I get 2 lots of x minus 1 equals y minus 1. So 2x minus 2 equals y minus 1. And then I am going to add 1 to both sides to get 2x minus 1 equals y, which is traditionally written as y equals 2x minus 1. So what I've done there is I've found the equation of this tangent here. And I've done it by finding the gradient of the tangent at the point where x equals 1, and also finding the y value of this point, which again I can see is 1, 1 from my graph. So what I'm going to ask you all to have a go at now, and I'm going to give you sort of 5 minutes. I'm not going to be able to do this like a normal lesson. Normally in school, obviously I'd go around and see what people are doing, but if I start getting everyone to shout out, it could turn into pandemonium, and also the external students will think I'm not going to this place, it's mad. So what I want you to do, I'm just going to I'm going to leave this working on the board. I want you to try and find, and obviously I'm going to go through it afterwards, so find the equation of the tangent to y equals x squared at the point where x equals 3 over 2, which is 1.5. Now I'm going to show you what that means in terms of the graph, So I'm going to zoom in on this a bit so I can see 1.5 more easily. There we go. So I'm looking for x equals 1.5, which is here. And I've got the tangent at that point where x equals 1.5, and I want to know the equation of that tangent. So remember, this tangent is a straight line. So in order to find the equation of a straight line, I need the gradient of that line, and I also need a point which the line passes through. Okay, I need a point which the line passes through. So I'm going to give you a few minutes. I'm just going to pause. I'm going to mute my microphone for a minute while you have a go at that. Right, so let's have a little look at this then. So I said if you want to find the equation of a straight line, you need two bits of information. You need the gradient and you need a point which it goes through. So can I please ask someone to tell me what is the gradient at the point when x equals 3/2? So we're looking at this tangent here. So we've got x equals 3/2, which is 1.5. What's the gradient at this point? If anyone who's got a mic would like to share that?
3.
3. It is indeed 3. So I can say here, my gradient is 3. Now, I also need a point that this goes through. Now, in the previous question over here, I said that the point was...
Sir, how do you know it's 3?
Because the gradient, if we look at this table here, we figured out that the pattern with the gradient is that the gradient's twice the x value. Does that make sense, whoever it was who just...
Oh.
Yep. So that's what we found out. I mean, that's not a proof, really. We took a few points, it seems, to follow a pattern. We'll look at exactly how we can find what the gradient is. But for this one, we said that if we when x was 1, the gradient was 2. When x was 2, the gradient was 4. When x was 0, the gradient was 0. And we just sort of said, well, let's assume it follows that pattern. Which I know it does follow that pattern. Like I say, I haven't proved it to you, but it does. We also need to find a point.
I'm in now, though.
Thank you. Can we only answer questions, please? So we also need to find a point that this line passes to. Now I've told you that the x value of it is 1.5. What I need to know also is the y value. So what's the y value of that point which our tangent passes through? Could anyone tell me what the y value is?
2.25.
2.25. How did you get that, Mr. whoever that was?
You just look across onto the y, and you see how far it goes up and where it intersects.
Okay. Yes, I see what you're saying. Although that wouldn't be exact. I wouldn't. How do you know it's 2.25 and not 2.26 or 2.24? There's another way of knowing that it's exactly 2.25. Could anyone tell me how we know that's exactly 2.25?
3 over 2 squared is 9 over 4.
Perfect. So I know because it's on the curve y equals x squared. We know that the y value is going to be 3 over 2 squared, which is 9 over 4, which is 2.25. But I'm going to leave it as fractions. So I'm going to use this m equals y minus y1 over x minus x1 that we used earlier. For some of you, this is probably brand new. For others, it's not. But it's really important that we do use this in A level. So this is something, if you're going to take one thing from today, and nothing more, then make it using this. Okay, so I'll pop that in, and we're going to say 3, which is our gradient, equals y minus 9 over 4 over x minus 3 over 2. Again, that y1 and x1, they're the points that we know are on this curve. I'm going to multiply by x minus 3 over 2. To give me 3 lots of x minus 3 over 2 equals y minus 9 over 4. Expand this bracket out, 3x minus 9 over 2 equals y minus 9 over 4. I'm just going to have to rub some stuff out over here to get a bit of space.
So I can't see anything. I just see a black screen.
Okay, I'll have to deal with that in a minute. I'll pause the recording in a second and I'll see how people are getting on. Okay, sorry, I can't really fix that right now. And then I'm going to multiply both sides by 4. So I'm coming from here. I'm going to multiply both sides by 4 just to get rid of those fractions. And this is another important skill. So if you're going to take 2 things away from this session, then this is the second one. 18 equals 4y minus 9. And then I can rearrange that to maybe say 12x minus 9 equals 4y. So 4y equals 12x minus 9. And quite often in A-level questions, they ask you to give the answer in the form where that all the coefficients are integers, and that's why I've done that. That's why I've multiplied by 4. So you might be thinking, well, I'm used to giving y equals, but quite often you're just asked to make it all integers. So ay equals bx plus c or something like that. Right, I'm just going to, in fact, I can't pause the recording. Let me reshare my screen. So I'm going to close the sharing of the screen and I'm going to reshare it. Okay, who was it who said they couldn't see my screen a second ago?
Yeah, it's calm now.
It's calm, but is it visible though?
Yeah, DK.
Excellent. No idea what's going on there. Okay, so what we've looked at there is for a simple graph where we've got y equals x squared, and we found out that the gradient is twice the x value. But let's look at a different function. So I'm going to get rid of this. I'm going to get rid of these points. I'm going to put a different curve up. So I'm going to put x squared plus x. Okay, so it's only slightly different. It's x squared plus x rather than just x squared. And we're going to see if we can find out what the gradient is at any point here. So I'm going to plop a point on, and then I'm going to put a tangent on, and then I'm going to have a look at what's going on. Now again, this is not a proof, but we're going to see if we can plot some values. So what do we know? I'm going to put this into a table in a second. When x is minus 1, what's our gradient? When x is minus 1, can anyone tell me what our gradient is?
Is it -1?
-1.
It is also -1, absolutely. Let's see when x is 0. When x is 0, what's our gradient?
1.
1.
1.
When x is 1, what's our gradient?
2.
No,
It's 3.
It's 3.
it's
3.
3. It is 3, yes. Okay, so, and when x, we'll do one more. When x is 2, I'm going to have to zoom out a bit to do this. When x is 2,
9.
can anyone see what that gradient is? So if you think it's gone,
5.
yeah, it's 5.
9.
Perfect, it's not 9. So
It's
if we-
4.5.
okay, thank you for the shouting out, please. We've been very good so far. Let's keep
Sorry,
it that way.
sir.
Thank you. So I'm going to just put a new whiteboard up here. So what we just discussed, so we've got the curve y equals x squared plus x. And we've said that we've looked at values for x and we found the gradient of the tangent at each of these. So we said when x was -1, the gradient was -1. When x was 0, the gradient was 1. When x was 1, the gradient was 3. And when x was 2, the gradient was 5. Now, is anyone able to give me a function, a formula for the gradient in terms of x, please?
2x plus
2x
1.
plus 1.
It is 2x plus 1. Right. So is there any way, and I'll remind you, when y was equal to x squared, the gradient function was 2x. When y equals x squared plus x, the gradient function is 2x plus 1. I just want you to take a minute to think, what if y was equal to, let's see, x squared, 2x squared plus 3x. What do you think the gradient function of that might be? If anyone's able to. I'll give you a minute to think and then I'll ask.
4x plus 3.
4x plus 3.
Who was the first person who said 4x plus 3?
Don't know. It might have been me. I'm not sure.
I thought it was a female voice. I don't think it was that voice.
Okay.
It was me. It was me.
I think it might have been me
Yeah, it's
starting
that.
to
It's
say
that.
it,
No,
but
it was
didn't-
me, Tom. It was me.
That who's that girl then?
Simran.
Me.
Simran. Okay, hello Simran.
Yeah.
How did you know it was
Hi.
4x plus 3?
Because you take the square of the x squared times it by 2 to
Y
get
times it by 2.
4x.
Y times it by 2.
I don't remember why. I just remember doing dy
Where
over
did
dx
you
and
get the
further
second?
maths.
Where did you get the second 2 from?
So the first one is the coefficient of the x,
Yeah.
and
Okay.
the second one is the x squared.
Yes.
From
So
the power of
essentially,
x.
you've said you take essentially this power here gets multiplied by the coefficient.
Yeah.
And then what happens to the power?
It decreases by 1.
Okay. So what's the power here then? There's if I put a circle here, what's the power that's here?
1.
Yeah, it's actually a 1, isn't it? So that 1 gets multiplied by the 3. And what do I do to this power?
Decrease it by 1.
Which gives me,
0.
and what is x to the 0?
1.
Yeah, so I don't need to write that x to 0. So exactly, my gradient becomes 4x plus 3. Now, I haven't proved that here, and I don't want to prove that today. All I've done is sort of shown you that it seems to follow that pattern. It does seem to follow that pattern. Now, what if I had, so let me get a new one up. So if I put in 2x squared plus 3, sorry, 3x, that's the curve 2x squared plus 3x. If I add a 1 to it, does it change the gradient at any point? So if I get rid of that 1, is the gradient affected by adding the 1? Does that 1 change the gradient? What do we think?
No.
No, who was that?
Michael.
Who? Sorry, you're right. Who was it though? Just so I know who I'm talking to.
Michael, sir.
Michael. Oh, hi, Michael. Michael Pearson. Right. Okay. So it doesn't, because all it does, do you know the transformation that occurs when I just add a 1? Michael, what's the transformation that occurs to that curve when I add the 1?
It goes up by 1.
Yes. So it's a translation.
Oh, yeah.
Yeah, it's a translation of 1 in the y direction. Yeah, or in layman's terms, it goes up by 1. So what I'm going to do is I'm just going to put I'm going to show you that. I'm going to put a couple of tangents on there. And we can see that if we take the tangent when x is 0 on both of those curves, they're parallel. Those lines are parallel. The tangent has, it's the same gradient at least. Obviously, it's a different line, but it's the same gradient. And I could change that +1 to a +2, to a +3. The gradient doesn't actually change. Obviously, the line changes because it goes to a different point, but it's the same. It's the same gradient.
Why doesn't that change?
Because all you're doing is translating the curve. So when I add, I'll show you. Let's see. See if I can change this to a +a and add a slider. It's not letting me do that. Let's see. Sorry, it's not allowing me to add a slider for some reason. I might have to draw a new one. So y equals 2x squared plus 3x plus a. Okay, this one's better. So let me get rid of that. Right. Okay. So what I'm going to do now is I'm going to put a point back on there. Let's put a point. We'll make another tangent. This is a nice thing with GeoGebra is you can put an unknown. So what I've done is in my, where is it? Right, you can see here. So this is my function now, and where it says +2, I actually typed in +a, and then it creates a slider. So you can see, Evan, that no, when I'm just changing the a, when I'm just changing the constant value, the curve stays the exact same shape and it just moves up and down. It just translates up and down the curve, and the gradient doesn't actually change. Can you? I'm not going to ask if you can understand why that happens, but can you see that happening, Evan?
Yeah.
Okay. Now, interestingly, in fact, I might just reset this because I've got quite a lot going on there. If I was to say y equals x squared plus ax plus 3, so this time my slider is controlling the coefficient of x. So if I then put on a point here, so let's put on this point here and find our tangent. Okay. And if I go back to my slider, I can see that as I change the a value, that the gradient of the tangent when x equals 0 it becomes very different. Now, if I then move, it doesn't seem to let me move this point, annoyingly. Okay. But again, I can see that changing the x coefficient definitely changes the gradient, whereas changing the constant does not change the gradient. And the same would happen if I change the x squared coefficient. So GeoGebra is it's really useful to get to grips with GeoGebra, especially once you start doing the geometry work and lots of other things as well. So it's a good part of A level. Okay. What I'm going to do is I'm going to stop the recording now, because I think that's enough sort of looking at calculus and things like that. And then I'm going to see if anyone wants to ask any questions about the course. I won't record this for the externals because I don't think it'll be particularly useful for them. They can email me if they have any questions over the course anyway. So let me just get this up. There we go.